Quadratics part 4. Now we're almost done with sort of all of the tools you need in your toolkit for solving quadratics. This is the last sort of special case before we really go into the next level of sort of challenge and rigor that you guys need as you're building to sort of college level understanding of math. Because remember, quadratics is the most important thing you can learn if you want to go to college. For engineering, for science, for anything, quadratics is the basis for college level math. So you notice that this one is slightly different than the other quadratics we've dealt with because there's no c value. I see a number with x squared, I see some number with x, but I don't see a number at the end. So our factoring is actually going to be even easier when we don't have that c, that regular number, which we're going to call the constant for the rest of the year. Whenever you have a regular number without any variable, we call that the constant. So this quadratic here does not have the constant. It does not have the regular number. So our factoring becomes even easier. We don't have a 2 by 2 box. We're just gonna have a spot for the 2x squared and for the negative 8x. And now we're still, as usual, going to pull things out on either side. So we have to ask ourselves, how do we get to 2x squared? Well, the only way will be 2x times an x, because whenever we have a variable with no number, we assume there's a 1 out there, so 1 times 2 is 2, x times x is x squared. Then ask yourself, 2x times what gives us negative 8x? Oh, it'd have to be negative 4. Negative 4 times 2x gets us our negative 8x. So in this problem, we just have 2x times x minus 4. We essentially just found the GCF, the greatest common factor. If we redistribute this, 2x times x is 2x squared, 2x times negative 4 is negative 8x, we know we have an equivalent equation. They're the same thing, they just look different. Now we can still get our solutions. Anything that has an x, guys, needs to be set equal to 0, including that 2x, and then this problem as well. We divide by 2 and we end up with x equals 0, which is totally correct. And then we add 4. Oops. So then x will also equal 4 there. So now you guys should be able to be given a quadratic equation like this and instantly know what strategy we're going to use. So the first thing I see is I see x squared. So I know it's quadratic, and I also see a regular x, so I won't be able to use square roots. The only time you're able to solve square roots, like quadratics part 2, is when you only see x squared and there's no regular x out there. So since this is a good old classic quadratic, I need one side equal to 0. So I'm going to add my 3x here and line that up with the like term on the other side, the regular x. Then I'll add the 5 here and line that up with its like term, the other constant. Haven't touched the 3x squared yet. Negative 15x plus 3x is negative 12x equals negative 3 plus 3 is 0, negative 5 plus 5 is 0. So now that I have one side equal to 0, I can continue. Once again, I notice there's no constant. There's no c value. So this is going to be an even easier factoring. It's just going to be a simple little 1 by 2 box. One for each. And now we'll figure out how to multiply there. So here, 3x times x gets us 3x squared. So then what times 3x gets us to negative 12x? Just a negative 4. So we see our factors are 3x times x minus 4. And now you're ready to set those equal to 0 and solve. Once again, x equals 0 over here. And you guys will start noticing in your math, every single time that you have just a regular x like that, when it's a sort of a more simple factoring of a quadratic without a constant, one of your answers will always be 0.